ID the Future, a podcast about evolution and intelligent design.
If Darwin's theory of biological evolution can't explain the origin of life, then what can? Does intelligent design have the explanatory power to stand in the gap? Welcome to ID the Future. I'm Andrew McDermott. Today we're bringing you the second half of an engaging conversation between philosopher of science Dr. Stephen Meyer and synthetic organic chemist Dr. James Tour, as they discuss the current status of origin of life research and which scientific theory best answers the question of life's origin. Dr. Tour is a professor at Rice University, renowned for his work in nanotechnology and his skepticism toward the current scientific models explaining the origin of life. Dr. Meyer is author of Darwin's Doubt, The Explosive Origin of Animal Life and the Case for Intelligent Design. In part 1, the two men explored why the question of life's origin remains stubbornly unsolved, with current research demonstrating more about how life didn't form than how it did. Today, in part 2, we pick up that thread by delving into the crucial concept of information. Meyer and Tour explain what it is and how it defines the origin of life question. Dr. Meyer will argue that the functionally specified information found in every living cell points to intelligent design as the best explanation for the origin of life. The pair also ponder the profound mystery of what life is, beyond its chemical components, touching on arguments of purpose or teleology in life. As we jump back into the conversation, host Peter Robinson is ready to switch gears from discussing the current impasse of origin of life research to unpacking the all-important ingredient for life, information.
Listen, can we go now? I believe I understand the dead end. Could we go now to this question of that DNA raises, the question of information?
Sure.
All right. This is Steve Meyer in your book, Signature in the Cell. Quote, DNA sequences do not just possess information in the strictly mathematical sense, developed by the famed MIT scientist Claude Shannon in the late 1940s. Instead, DNA sequences convey instructions. They perform functions, they possess specified information. Okay, so you've got as far as I can tell, it's really important to understand this, but you're going to have to help me do that.
Sure.
So we start with Shannon information,
right.
And as I understand it, Shannon is working on telecommunications. He's trying to come up with mathematical algorithms that let you convey lots of phone calls down a
communication channel.
Communication channel, right. And he has this basic insight that the information an event conveys is inversely proportional to the event's probability. So, the sun comes up this morning, it tells us nothing new. That's a very probable event. The sun doesn't come up, and we know it is conveying information about some new event in the world. Is that roughly correct?
Roughly, it might be.
You're not happy with that.
Well, maybe coins or dice might be better ways
Go
of getting at it. So if the basic idea of Shannon information is that information is related to the reduction of uncertainty. That's the intuition. So if I flip a coin and it's got two sides and it comes up heads, now I've reduced a certain amount of, a quantifiable amount of uncertainty. It was either going to be a head or a tail, and now it's a head. But if I roll a die, there are 6 possible outcomes, and so the amount of uncertainty reduced when it comes up 3 rather than 1, 2, 4, 5, or 6 is greater than the amount of uncertainty reduced by flipping the coin. And so you can see that the information measure, the amount of uncertainty reduced, is related to the probability of the event taking place. The head has a 1 in 2 chance, the die, one side of the die, a 1 in 6 chance. So there's more uncertainty with the more improbable event. More uncertainty reduced when the more improbable event occurs. And so what Shannon does is he's able to quantify the amount of information carrying capacity in a string or bit string. But what he can't do, and which he was very explicit about saying, is that his mathematical measure of information carrying capacity doesn't tell you whether the string the series of characters is meaningful or functional or specified to perform a function in any way. So a very simple example that conveys the difference is you might think of, if you type at random 20 characters on your typewriter keyboard and put that string out, and then right below it you might write a line of poetry, time and tide, wait for no man. Both strings have identical amounts of Shannon information because they're using the same alpha character symbol system, but one has a qualitative element that the other doesn't have. They're both equally improbable, but one has a qualitative element, and that is that the arrangement of the characters is specific to perform a communication function. And that's the kind of information
that we see. Go ahead.
Well, it's the kind of information that invariably indicates a designing intelligence. If you see a line of poetry that's meaningful, you right away know there was a poet. But if you just see random characters like that, it might be that somebody arranged them for that in that way, but it's also could be the product of monkeys at the keyboard. So so early on in the 1950s, we have Crick with his sequence hypothesis. He's working in the immediate wake of the Shannon information revolution, and he specifies that DNA does not have mere Shannon information. He says that the sequence of bases in DNA are sequenced specifically to perform a function. And so that you have what an origin of life researcher named Leslie Orgel coined this term specified complexity. Complexity is a synonym for improbability, and so you have a specified improbable arrangement. When you have that, that's what we mean in ordinary parlance by information, or in our careful writing on the origin of life problem, we define what needs to be explained as the origin not of Shannon information, but of specified information or specified complexity. Something like tide and tide, wait for no man, as opposed to the random characters of the monkey would type out. And Crick was absolutely adamant early on that DNA doesn't have just Shannon information, it has specified information.
Now we come to the moment when the two of you become really controversial. Up to this moment, pointing out that the Urey-Miller experiments have gone nowhere, that we know less than nothing about where the origins of life might have come from, less than nothing, as you put it. Actually, what we've done is demonstrate ways that life probably didn't form. That, as I take it, you two are very irritating to the scientific community, but they can live with you.
Well, even our friend Richard Dawkins acknowledges that no one knows how life evolved by undirected chemical evolutionary processes. So you're right, this is actually not controversial. The critique is not controversial at all. Yeah, it's annoying, but not controversial.
Right. So here's the point where the two of you cross a line. And by the way, I feel an urge to grab you by the collars and save you from crossing over that line. But I'll get to that. This is Steve in Signature in the Cell, quote, "The functionally specified information in the cell points to intelligent design, for which every one of our listeners is going to say, oh, I know what they mean. They mean God. Intelligent design as the best explanation for the ultimate origin of biological information. Why? Experience shows that large amounts of such information, especially codes and languages, invariably originate from an intelligent source." I want to repeat that. Experience shows, our own lived experience as humans, when you see a line of poet, well, as Bill Clinton said, when you see a turtle on a fence post, you know it didn't get there by itself. We recognize intelligence. Invariably originate from an intelligent source, from a mind or personal agent. In other words, intelligent activity is the only known cause of the origin of functionally specified information, close quote. So what Meyer is saying, now pay attention to this one, Jim, because this guy is just radioactive. What Meyer is saying here is that when we see DNA in the simplest cell, we really have no choice. We have to suppose that there is some intelligent design behind it. Are you going to let him get away with that?
No, I'm sympathetic to what he's saying, because we have no other answer. I mean, I don't normally go down that line to say that. There's so many problems before you even get to thinking about this question of intelligent design and this information. But I talk about the information. We have no idea how to solve the information, but there's so many steps that you have to get through before you even get there. You want DNA. DNA isn't going to do anything unless it has lots of enzymes supporting it from around so that it can help to translate it to RNA. And RNA isn't going to just start reacting with amino acids on its own. It needs all sorts of support enzymes. So there's all these pieces that are missing. You don't even get to take advantage of the information that's there because the chemistry doesn't let you. The chemistry just doesn't let you.
Peter, I've really appreciated Jim's work because he's addressed not just the information problem, which has been the main focus of my work, but all the biomacromolecules that have to be prebiotically synthesized to make it possible to even begin to think about the origin of a cell. You have to have the saccharides, the sugars, you have to have the lipids, you have to have the proteins, the enzymes, you have to have the DNA. There's all these different classes of molecules, but I focused on the information question, and I think that is, at some level, the most fundamental question because it's all about not just the presence of the constituent parts, it's about how they need to be arranged in order to perform biological functions.
But see, even the DNA is a piece of, it's this informational code, but everything in the cell is informational code. The saccharides, the way sugars are put together, bears information. That's how cells tell one another apart. I mean, they bump into these other cells. They see what the saccharides are, and
signaling molecules.
Yeah, right? It's all based on this. All the amino acids, all the proteins, those all have information so that they know what molecule to build. Every piece of the cell is information. I mean, and so to just focus on DNA being information, I mean, every piece of your cell is information. How does this information get translated? If you don't have fidelity in information transfer, we tried this years ago in my lab to try to make a starting molecule and have it make a duplex, a daughter molecule just like itself, not using biological entities. And what happened was the fidelity killed us, meaning that it was only 70% pure. So you have 30% still in there, now reproducing junk. And
you get
before you know
error
it,
catastrophe with each generation that gets worse and worse and worse because you're not.
It's just a mess. It's just a mess.
So, boys, there are two ways you could argue. I think you could argue, and this is I'll give you the easy one. I'll give you the one that, for the sake of your careers, you really, follow this one. If you take my advice,
it's too late for me.
You're both in plenty of trouble, but follow this one, and the trouble will be at least moderate. You can say, wait a minute, even the simplest cell contains DNA, and then Tour says, DNA, you don't know the half of it. The saccharides, and the cell is jammed, it's bristling with information. And the summary of that line of thinking is, not only do we not know how the origin of life began, but the idea that the question is uninteresting or easy, or that the universe, given enough time, would have produced it in a random way, that, ladies and gentlemen, given the state of knowledge today, that is preposterous. And stop. You could just stop there. But the two of you, no, you may not yet.
I want to explain why I didn't.
No, you'll get a chance, but I want to give you, but the alternative is the two of you, here, let me read a quotation, because you keep going, you cross the line. Jim, even you, I'm going to quote you from your article one more time. Those who think scientists understand how prebiotic chemical mechanisms produce the first life are wholly misinformed. Nobody understands how this happened. You're good so far. It would be far more helpful to expose students to the massive gaps in our understanding. So far, so good. And a lot of people thinking, okay, good, Jim, just stop there. But you don't stop there. You go on. It would be far more helpful to expose students to the massive gaps in our understanding. Then they may find a firmer and possibly a radically different scientific theory, close quote. And everybody says, there goes Tour, opening the door to God. You guys crossed the line. It's not enough to say science should be much more humble about its claims, because something that we thought we would get to for the last 150 years, not only have we not gotten to, it baffles us more than ever. You guys go on to say, and what we see is evidence of intelligent design.
I don't know how you can take what I just wrote and suggest that I was suggesting God. Why can't we just have a wholly new scientific theory?
Which would be?
Which would be, I don't know yet.
Okay, that's fine.
I don't know yet.
That won't satisfy Steve.
He's not in quite as much trouble as I am.
Okay, so we have here at this table Jim Tour, the eminent Jim Tour, thousands of papers on materials that I can't even begin to understand. Brilliant man says, it is enough to say we don't know. And Steve Meyer replies,
there's a logic, a scientific logic, that points to the role of intelligence in the origin of life. There's a famous information scientist named Henry Quasler, who was one of the first information scientists to apply information theoretic concepts and informational concepts to the analysis of the molecular biology, to DNA and RNA. And he said that the creation of new information is habitually associated with conscious activity. That's what we know from our uniform and repeated experience, which is the basis of all scientific reasoning. In my PhD thesis, I studied the methods of historical scientific reasoning, pioneered by, among others, Charles Darwin. And the key idea there in historical science is that if we want to explain an event in the remote past, we want to explain it by reference to causes which are known to produce the effect in question. And I came across this principle first in one of Darwin's mentors, Charles Lyell, the great geologist, who said essentially that. And I asked myself a question. I said, well, what are the Lyellian phrase was by reference to causes now in operation. That's what we want to explain, past events by reference to causes now in operation. And I asked myself a question, what is the cause now in operation for the construction of specified information or digital code? And I could think of only one. And I ended up writing a 500-page book looking at all the different proposals that had been made for explaining the origin of that digital code, and all of them came up short either theoretically, empirically, or both. But we do know of a cause that produces specified information, and that cause is intelligence, it's mind. And so using the Darwinian logic of the historical sciences, it's actually possible to affirm the intelligent design is the best explanation for the origin of information. Whenever we see information and we trace it back to its ultimate source, whether we're talking about computer code or information in a radio signal or hieroglyphic inscription or a paragraph in a book, we always come to a mind, not a material process. And so the discovery of information in a digital form, in a specified form of information at the foundation of life, I argue, provides a powerful indicator of the activity of a designing mind in the origin of life. And that's using the standard historical scientific method of reasoning that Darwin himself used.
Okay, and as far as I can tell, so you cross one line, but you do stop short of another line, meaning you're not going to start talking about God and say that this proves the existence of the God of the Hebrew Scriptures or the God of the Baptists or the God of the Presbyterian. No, it's intelligence, and there's a long, long way from what we can say must have been involved in forming DNA. There's a huge distance from that to Hinduism, to any known religion. And so you're being within your own
in my
life,
work on
within
the origin of life,
you're quite modest. You draw lines yourself. Is that right?
Well, in the book Signature in the Cell, I argued for the need for an intelligent agent of some kind to explain the origin of the first information necessary to produce the first life. I do think you can make further arguments that point not just to a mind of some kind, but to a sort of a generic theistic understanding of God. But you have to bring the cosmology and the physics in, the fine-tuning and the origin of the universe. And so I have a subsequent book that actually looks at the question, what is the identity of the designing intelligence? But from
is The Return of the
God hypothesis. But in Signature in the Cell, I argue that a mind of some kind is required based on our uniform and repeated experience of what it takes to cause the origin of information, specified information.
Okay, Dr. Tour, are you down for any of this program, or do you want to just say?
Well, I mean, I wish you could see what I see, because then you would, even if you just take a cell, very simple cell, and you ask scientists to look at this cell, what is going on? If you just put molecules, align them in that way, is it going to run? Is it going to operate? We don't even know what got this cell going. We don't know. I mean, so you should ask a scientist, a cell just died. What is it we just lost? I mean, all the molecules are right there. Could you get it going again? We don't even know how to describe what life really is when it comes to even a simple cell. We don't even know that. That's how clueless we are. I wish you could see this because you don't understand the magnitude of the human deficiency in even understanding what life is in the simplest of organisms. And people will say, well, life was much simpler at the start of the evolutionary process. This has already been calculated. Bioengineers have already figured out what is the minimal operation that you need. What are the fewest components that you need to have a cell operating?
Right.
And you take that and, okay, so let's say we make all of those components. By the way, none of those 15 components have been made. None of them. Now, if you could make them, now what would you do?
Under realistic prebiotic conditions.
Yeah, even if you could make them in your current lab. I'll give them their own labs. Make them, or just take them from a living cell. Go to a living cell, use that as your supply chain. Take it from the living cells. Now what do you do? Just putting them in proximity? Is this going to run? Nobody in the right mind would say yes. No scientist would say, it's not just putting them together. You don't know how to put them together, but even if you could, now how does it even start running? We don't even know what we're going toward, which gets back to that philosophical experiment that his professor was talking about. What are we going toward in life? We don't even know what life is. Molecules don't care about life. Molecules are random. They don't move toward life. There's no propensity for a molecule to move toward life. It has no brain. It has no action that wants to bring it toward life. They don't know. I don't know what you want me to do. I'm just here. What do I do? And then even if we could say, I want you to move toward life, you'd be like, okay, just tell me which direction to go. I don't know.
Jim has an amazing talk looking at some of the prebiotic experiments. And they're basically implementing complicated recipes. They start with purified chemical reagents, and then they combine them in just the right measures, the right proportions, under the right conditions and temperatures, and then they get a reaction, and then they pull out what they want, and then they go get those same chemicals off the shelf in a more purified form, and they take the next step, and it's one step after another, and at every step along the way, there's this problem of what's called investigator interference. And if you go back and you relate this to the idea of an informational measure, if we think of information as excluding one option and electing another, a bit of information, a head, not a tail. At every step of the way, the investigator is excluding one option or excluding maybe a whole bunch of options and electing another. They're inputting information to move the experiment in a modestly life-friendly direction. They're nowhere near, as Jim is saying, actual life. But the logic of these simulation experiments actually supports intelligent design. Because the idea is you're simulating what must have happened on the early Earth to get life to go from simple chemistry towards more complex, life-friendly chemistry.
Repeated intelligent intervention.
There is a repeated intelligent intervention in every one of these simulation experiments. So what's being simulated?
Every one of those simulations is, you say it's intelligent. It's stupid. It's stupid because it doesn't get you there. They are doing things that in their own mind is intelligent, but it's stupid because it's not moving there.
Jim, could I ask, this is nowhere in my script, and maybe it's a dud of a question. But I'm going to ask you because you are such a brilliant man and you understand things at such a level of detail. If I take a petunia seed and it comes to me in the packet from Burpees, and all these seeds are little dead things, and I put it in a pot and I put some water on, now I can predict and you can predict that we'll come back in 2 days and there will be a little shoot, and a week later there will be a flower. But if I say, why? How did that happen? Are you telling me that at the moment of life, at the moment something passes from inertness to life, that remains a mystery to us today?
Yes, it remains a mystery. What is the very even thing we're describing when we talk about life? I've had scientists, I used to do this demonstration for my own children. I said, watch, I'm having scientists over tonight. Watch what's going to happen. I said, you have a cell, it just died. What is it you just lost? And then they start arguing with one another. There were 2 questions. I said, what is it you lost and how would you get it going again? They could never get to how we get it going again because they could never figure out what it is we just lost when the cell died. That's how mysterious life is. Now, that's not to say that we won't one day know. I can never say that. As a scientist, I can't say we will never know. There's a whole lot of things we've figured out. If you asked a man in 1700, will we ever be able to walk on the moon and come back? He'd be like, no, we don't even have space flight. I mean, how can I say? How can I say? I don't know what the future holds. But all I know is it's not going to happen tomorrow. It's not going to happen in 10 years with 40 million euros being thrown at this thing. That's more money down the drain. You're better off letting the taxpayers keep that money because they're going in the wrong direction. We don't even know what we're going toward.
Okay. And this is where Jim and I differ just a little bit, because I think these origin of life experiments have actually revealed what is necessary to move chemistry in a life-friendly direction, and that is intelligence. They are providing evidential support for the intelligent design hypothesis because of the logic of the simulations.
Let me flip the question here. Why is science as a profession so hostile to intelligent design, to the notion of intelligent design? If I Googled on critiques of intelligent design, I just type in those words, and wow, do I get hits. The American Association for the Advancement of Science, quote, "The lack of scientific warrant for so-called intelligent design theory makes it improper to include as a part of science education." The American Society of Agronomy, I didn't know such a thing existed, but there's an American Society of Agronomy, quote, "Intelligent design has neither a substantial research base nor a testable hypotheses as a scientific discipline." The American Chemical Society, "We urge education authorities to support curricula that affirm evolution as the only scientifically accepted explanation for the origin and diversity of species," close quote, even though everybody knows evolution doesn't even attempt to answer the question.
They say for the origin?
I'm quoting you. I got this off the web.
Origin?
Who
No,
knows?
no.
We urge education authorities to support curricula that affirm evolution as the only scientifically accepted explanation for the origin and diversity of species.
This is how stupid this is. I mean, scientists are like everybody else. We want to allay our fears. We don't want to look bad. We don't want to spend 40 years doing things and people say that was a bunch of nonsense. I mean, we're just like everybody else. And they keep throwing this stuff out there, and then you oppose them and they get all upset with you and they don't want you in their little societies. And it's like Groucho Marx said, I don't want to be part of a society that would have me. I mean, who wants to be part of this? This is really nonsense what these people are putting forth because you can't even define this thing. And that's what all the experiments are showing. We need something radically different. I don't know what that different is, but all I can tell you is everything that we are doing now is not getting us there.
Okay. There's an historical background to this because science arises in the 17th century in a decidedly theistic milieu. And the design hypothesis was part of the practice of science because scientists have...
Galileo, Kepler,
Newton.
Galileo had his troubles with the church. He believed, he was a believer in God. All these early scientists were
Newton, Boyle, Kepler, they all made design arguments.
Right.
Okay, and because there are two contexts of scientific inquiry. There's how do things function? If I look at an automobile, I can understand in terms of the laws of internal combustion. But I can't understand the origin of the automobile apart from Henry Ford. I can't understand the origin of I can understand the iPhone by reference to the electronic equations, E equals IR. But I can't understand it apart from Steve Jobs. And so the scientists, beginning in the late 19th century, wanted to say that the kind of explanations and descriptions we use to explain or describe the ongoing operation of nature, and they would be properly materialistic processes that would be invoked, are also sufficient to explain the origin of things. And we have to limit ourselves to materialistic explanations for everything. But there's a fallacy
there. That just doesn't work.
It doesn't work. Well, it not only it may work, but it hasn't turned out to work. Because the problem is if you're asking about the origin of life, there are two basic possibilities. It might be the result of unguided, undirected material processes.
Right.
But it may be also the result of the activity of a mind. And if you decide in advance you're not going to consider the mind, the creative intelligence option, then you will necessarily elect a materialistic explanation, and it may not be the best because the evidence you have may be actually pointing to a different type of cause. And that's the argument for intelligent design, that when we see this specified information, this is an indication of the activity of intelligence. This is what we know from everything in our uniform and repeated experience, which is, properly speaking, the basis of all scientific reasoning. And so
if it is the goal of human beings to become smarter, to know more, not less, to become smarter, not stupider, to embrace options that seem reasonable and from which we can learn, rather than ruling them out and remaining willfully stupid, then intelligent design ought to be considered. Is that the argument?
Exactly. Otherwise, you have a sub-rational form of historical biology. It would be like walking into...
Are you calling Jim Tour sub-rational?
No, he's not sub-rational. He's doing great stuff. His work actually...
I'm trying to get a rise out of Jim.
Yeah, his work actually sets up the argument that I'm making.
Okay.
But if there are two possible options and you decide you're not going to consider one, then...
What kind of work is that?
That's not very... It'd be like going into the British Museum, looking at the Rosetta Stone and saying, well, I'd like to say that a scribe had something to do with it, but because I can't invoke creative intelligence as an explanation, I'm pretty much stuck with wind and erosion. But we know it wasn't wind and erosion. Something else played a role.
If I pick up this banner of intelligent design, to which I'm really quite sympathetic, it's a way of trying to negate everything that I'm saying. What I'm doing is I'm pointing out the obvious to everybody. There are so many scientists that don't work in the area of origin of life that agree with me. They see exactly what I see. This is not unique. This is not hard to see. Everybody sees what I see, except these guys that are working in the field.
He's performing a chemical accounting on these experiments.
And if I start invoking intelligent design, this is a way to dismiss me, so I don't even mention this.
Wouldn't be useful.
Yes, it's not useful for what I'm trying to put forward.
Gentlemen, a couple of last questions here. Shoot me down if you want to, but I'm going to take a step away from science, from pure science. Here's Thomas Aquinas in the Summa around the year 1270, quote, "Now whatever lacks intelligence cannot move toward an end unless it be directed by some being endowed with intelligence, as the arrow is directed by the archer," close quote. When Meyer looks at DNA and says the code implies a coder, Tour looks at these fantastically complex chemical processes required to produce even a nano vehicle of the kind you're working on, and says the assembly implies an assembler. And 750 years ago, Thomas Aquinas says the arrow implies an archer. Are we edging toward a point in which the teleological argument of Thomas Aquinas, the argument from design, the arrow implies an archer, the creation implies a creator, is that becoming intellectually respectable?
It's being revived by discoveries in modern science. I attended a conference early in my career, which I heard one of the leading origin of life researchers of the 1970s and 80s, Dean Kenyon, repudiate his own theory of chemical evolution, understanding that it had not explained the origin of the information in DNA. His book was called Biochemical Predestination. He gave a talk at a conference, said, "I can't accept my own work anymore." And he said, instead, it's time for the theologians to reopen it's time for the philosophers to reopen the natural theological question, which is, does nature point to the reality of a designing mind? And he then later embraced this new theory of intelligent design. And so what I think the teleological argument is the classical design argument, and I think it's being resuscitated, revived by discoveries in biology, such as the ones we've been talking about, discoveries in physics, such as the fine-tuning that the physicists are talking about. So I think the teleological argument is absolutely back on the table, and it's modern science that has put it there.
Jim?
I think that certainly scientists are seeing this, but they're not speaking up. They're not speaking up because they're afraid to, but they are seeing the barriers that are there, and there is no solution. The only ones that are not speaking up are the ones that are making their living from this thing. But nobody wants to speak up and get this abuse. My hope is that as young people come into this, these organizations will begin to change. That's my hope, that people will begin to be more open-minded here.
Okay.
There was a major article in Nature just a month or so ago, Jim, right, by two authors that are leading origin of life researchers, Johanna Xavier and Nick Lane. And Johanna had previously actually commended both Jim and me for raising these serious problems. And then she went on with Nick to write an article in Nature saying, hey, we can't keep sweeping this stuff under the rug. And so I think there is a shift starting. I think a lot of origin of life researchers are pretty terrified of Jim Tour because he knows the chemistry as well or better than they do. And he's saying, he's performing this chemical accounting and saying that these experiments are not plausible. They're not getting results that are plausible. They're not consistent with what we know about what would have been happening on the early Earth. We need another approach.
Last question. I'm going to step even further from science now. It just seems to me the question is one of aptness or appropriateness. What is the correct human response to life? So I'm going to ask a question and see if you think it's an appropriate response. That's the first question. The second question is whether it's useful in scientific thinking in any way. So the two choices would be the first choice, which we've already ruled out, which is 19th century. And they said, well, we have here this empty box, but it's going to be filled with Jell-O. The origin of life isn't terribly important or interesting. We'll get to it sooner or later. We know so much more now about the complexities of life and so much less about how it might have begun that an old verse came to mind, and here it is. I'm going to hit you with something from the late Bronze Age. This is from Proverbs. There be three things which are too wonderful for me, yea, four, which I know not. The way of an eagle in the air, the way of a serpent upon a rock, the way of a ship in the midst of the sea, and the way of a man with a maid. If we could hold ourselves in wakefulness, if we were truly woke, we would fall to our knees every day at the sheer mystery of life.
Yeah, I agree. I mean, life is utterly amazing. This is why I wrote an article that started out that the life that we see here around us, we can't explain. It should be like every other planet we've been to. It should be barren. And we have this ubiquitous life everywhere. You turn over a rock, it's teeming with life. There's life, and then you put it under a microscope. There's life. There's all of this life, and we can't even explain it. We can't even define what it is. And it's utterly amazing. Really, utterly amazing.
Steve?
I think that our familiarity with life, we see it all around us, has made us, it inures us to what's awesome about it. And one of the great things about molecular biology is that in opening up just the interior of the cell, just one, you see these amazing processes going on. I remember when I was first taking molecular and cell biology, and other students in the class would, with no particular ideological axe to grind in the discussion, would just keep saying, no way, how does that happen? We have a little animation on our website called Journey Inside the Cell that just shows the process by which this digital bit string is threaded through the ribosome, the transfer RNAs come, and in a very mechanical way, the information directs this process, ka-chunk, 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 of the building of the protein. And I've had a friend, an engineer, a longtime friend of my father's, an engineer, who had an epiphany just seeing that animation and thought, there must be a God. There must be a God.
Steve Meyer, James Tour, thank you.
Thank you.
For Uncommon Knowledge, the Hoover Institution, and Fox Nation, today from Fiesole, Italy, I'm Peter Robinson.
That was Dr. Stephen Meyer and Dr. James Tour, unraveling the challenges to origin of life research and discussing intelligent design as the scientific theory best positioned to explain life's origin. In case you missed it, look for the first half of this conversation in a separate episode. Meyer and Tour explore, in that episode, why the question of life's origin remains stubbornly unanswered in current origin of life research. Uncommon Knowledge with Peter Robinson is a production of the Hoover Institution at Stanford University, and we're grateful to the producers for permission to share the conversation here. For ID the Future, I am Andrew McDermott. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.